Greetings, and welcome to the DRI Fall Protection Training Module. This has a special emphasis on ladder safety because ladders are by far the largest fall hazard that exists in most workplaces, including here at DRI. The goals for this training include the following. You will understand the risks of falling from height or from a ladder, understand the requirements for fall protection and how to safely use ladders. Learn to recognize fall hazards. Recognition is a very important step toward avoiding a hazard. And learn to properly use different fall protection systems along with various ladder types. Fall protection matters because when we do not utilize it or we utilize it incorrectly, tragedies can occur. On an average year in the United States, a little over 500 workers die in fall-related incidents. But even when people don't die, they can still have very severe effects that can last a lifetime. In an average year, about 300,000 workers suffer a disabling injury in the United States as a result of a fall incident. And while most of us have an idea of fall protection being required when you're exposed to a very large height, most of these incidents that result in serious injury or death occur from falls at elevations of 20 feet or less. So we need to keep in mind that fall protection is important even for shorter fall distances. And next to motor vehicle collisions, falls from height are the biggest cause of workplace fatalities. This is why fall protection matters. There are standards promulgated by the Occupational Safety and Health Administration, or OSHA, that we have to follow. These standards exist in both the construction industry and in general industry to have fall protection and to ensure that there are no fall hazards that workers are exposed to. Now, both the construction standard, which you see here, 29 CFR 1926-501, and the general industry standard, which is all of 1910 subpart D, both of them have to be followed here at DRI when applicable. For the construction standard, or 1926-501, the duty to have fall protection is required anytime there's a threshold of 6 feet or more to which an employee might be exposed to a fall hazard. And in general industry, the standard is 4 feet. Here at DRI, we don't let anybody be exposed to a fall hazard of greater than 4 feet under any circumstances. Both the general industry and construction standards require protection from hazards beneath a work area, regardless of height. So in other words, besides being protected from a fall hazard, you also have to be protected from an overhead drop hazard. Basically anything that could cause an injury to a person falling onto or into, we must be protected. Here are some examples of common areas and tasks where fall risks can exist. Not all of these exist at DRI on a given day, but they're things that could exist, and some of these do exist at DRI every single day. There can be leading edge falls where you have 2 different levels, and if you're on one, you could be exposed to the fall hazard to the lower one. Hoist areas. Holes in surfaces, including skylights. There are buildings here on the DRI campuses that have skylights and other holes in them, like hatch openings. Ramps, runways, and elevated walkways. Scaffolding. Again, things happen on DRI's campus periodically where we have to have scaffolding built. Those are definitely a fall risk and also a falling object risk. Excavations or trenchings. Anytime there's overhead bricklaying or wall building. Wall openings. A lot of times whenever a space is being renovated, a window gets taken out and then you have a giant wall opening, which needs to be protected during such time as it remains an opening. And certainly any work done on a roof, whether it's science-based work, maintenance-based work, anything like that. Anytime you're on a roof, more than likely you're being exposed to a fall hazard of greater than 4 feet or greater than 6 feet. The types of fall protection that can exist include the following. Well, the most common form of protection for leading edges is guardrails. Here on DRI campuses, we also have parapet walls up on the roofs of some of our buildings, which kind of serve the same function as guardrails. They keep you from falling off the leading edge. Safety nets are another example. We don't see these a lot here at DRI, but you see them a lot of times at other construction sites. Safety warning lines. These are designed to tell you that you're getting too close to the leading edge and that you need to stay within the line system to do whatever task you're doing. Travel restrictions. This is exactly what it sounds like, where when you're using one of these types of systems, you literally can't get close to the leading edge because you're physically restrained from doing that. Personal fall arrest systems. These are the sort of the quintessential form of fall protection, where you have an anchorage point and a lanyard and a harness, and where even if you do go over the edge, the shock absorbing systems will keep you from hitting the ground. And the more limited versions of this would be the positioning or suspension harness and lanyard system, where you're kind of sort of like the travel restriction system you see here, where you literally can't fall farther than your own person height because the system is designed to prevent you from going any farther. We might not be able to completely remove all fall hazards from a workplace. When we can't remove a fall hazard, we mitigate it. Some examples of mitigating fall hazards including the following. If you have to have a hole in a working surface, such as a skylight or a hole that's needed for operational purposes, it must be covered or blocked by guardrails or cages during the time that it remains a hazard to workers. Leading edges and wall openings. Again, if you got a situation where maybe a new building is being built or a building's being renovated and the window comes out, and so now you have a wall opening or a leading edge, those have to be protected by warning line systems, barriers, or guardrails. Here in this picture you see examples of guardrail systems that they're not going to be there once the work is done, but while the work is being conducted, they're in place, and they protect people from falling out the wall opening. There's sometimes situations where a person needs to work at heights and they're exposed to a fall hazard, but they also need a lot of freedom of movement in order to be able to do the operational things up there that they need to do. In that case, personal fall arrest systems will be necessary. Now, personal fall arrest systems are complicated and they require extensive training for users. You can't just give somebody the equipment and say, go work on the roof. People that are going to use personal fall arrest systems need extensive training. The fall arrest system equipment must be selected and installed by a competent person. And there's a statutory definition of what a competent person is in the OSHA standards. Basically, it means someone who has the training and knowledge and experience to be able to recognize what's feasible, what's not, how things are supposed to work, what are some of the signs that a system is not working the way it's supposed to work. So being a competent person, again, it's not like a certificate program or anything like that, but it's a performance-based standard where, based on your training, knowledge, and experience, you can assess whether a personal fall arrest system is being installed and used correctly. Fall arrest systems must be inspected and maintained, and that includes the anchorage points and the lanyards and the harnesses. We can't just assume that they're going to work when we need them to work. They need to be inspected. The dates on them that say when they need to be replaced, those need to be looked at carefully. Harnesses and lanyards must be the proper size and length to avoid injury, not just from contact with the ground, but also from lower work areas. If you have a harness and lanyard system that absorbs the shock, but the person still hits the ground before all the shock is absorbed, then that was not the right system. And the harness has to properly fit the employee, in order to sort of, make sure that the shock is absorbed correctly and distributed across the body in a correct manner. The harness has to be properly fitted. Fall arrest systems You can't just leave a person hanging. Literally, you cannot do that. There has to be a rescue plan in place as well for employees who fall. A person who falls over the edge in a fall arrest system, they can't just be left dangling. They have to be rescued within 30 minutes or less, because suspension trauma is something that can happen to people where you get bruising, you get blood pooling, and people can actually go into shock and get very serious health outcomes, up to and including death, if they're not pulled out of one of these suspension scenarios and put down on the ground and given medical treatment promptly afterwards. So just because a person didn't get severely injured or die from hitting the ground doesn't mean that they're out of danger. They need to be promptly taken down. The safety straps that are part of a personal fall arrest system help to prevent suspension trauma, but it's still very important to have a rescue plan in place to make sure that in less than 30 minutes people are down from that system and they're not just swinging like a pendulum off the side of the building. A fall arrest system is a system. It has a lot of different components. One of the most important components of a fall arrest system is the anchor point. That's the thing that the lanyard is connected to that has to absorb a lot of force in order to protect workers. An anchor point has to be able to withstand 5,000 pounds of drop force. Again, because when a person falls over the edge, it's a force multiplier. It's a lot more than just that person's body weight that's being exerted on that anchor point. So an anchor point is a very serious thing. It has to withstand 5,000 pounds of drop force. They have to be selected and installed by a competent person. Again, the OSHA standards talks more about who is a competent person. It has to be someone that knows what they're doing. The fall arrest system must prevent contact with structures or objects below the work area. This is something very important to consider. If you've got somebody in a fall protection system, a fall arrest system, and they fall over an edge, but then before their fall is completely arrested and shock is absorbed, if they, for example, hit a steel decking 7 feet below, or a protruding I-beam or conduit or pipe or anything, they're not adequately protected. They were exposed to a fall hazard, and in fact that object that they hit after a 7-foot fall can be a fatal injury. So fall arrest systems must be designed to prevent contact with structures or objects below the work area. And you have to consider the potential for pendulum swings after somebody falls. Once somebody falls and the fall gets arrested, and of course they need to get pulled down before suspension trauma occurs, but then they will tend to swing like a pendulum for a little bit, and you have to think about, is there anything within the swing zone that can hurt them? Any objects, electricity, anything like that? These all have to be considered when you're putting somebody into a fall arrest system. This is kind of what you would see when you have a proper shock-absorbing body harness as part of a personal fall arrest system. It'll have a hook on the back, like you see here, to which the lanyard attaches. The lanyard itself has significant shock-absorbing characteristics to it, and it'll have the hook on one end and then a smaller little carabiner hook on the other end, or sometimes it has dual hooks, but the hooks on a lanyard need to be routinely inspected to make sure that they don't come out of place, because if they do, there's a potential that people could slip out of them. What you see here with the lanyard as well is that once it gets force loaded, that it will elongate significantly, and when that happens, it can't be used again. Basically, really all the components of a fall arrest system, other than the anchorage point, are designed for single use only. Once they've absorbed the shock and sort of saved the life of somebody from a fall hazard, they can't be reused at that point. Here's an example of a lanyard that is designed for 2 workers. And again, this is a normal and legitimate thing. You just need to make sure that whatever anchorage points that you're tied to are actually rated for 2 workers. But yeah, you can have multiple worker lanyard systems. The type of lanyard you see here, this is another type of shock absorbing lanyard, but this one kind of works more like a safety belt in a car in that when you're walking, you can keep pulling out a little bit more of the reel, so you can get a little bit longer lanyard. But then once it senses that a sudden jerk, it locks up. So just like a safety belt in a car, these are designed so that if a person, say, trips and falls over, it automatically freezes up, so nobody gets exposed to more than just like a person height fall. So these are the types of systems you see. This is an example of a system that where the person that's working at heights, their travel is restricted by the anchorage system they have, and in this case, the anchorage system is it's a long cable that has a device that attaches to it, and again, if it senses a fall, or any kind of pressure, it locks up so that a person is not exposed to more than just a very short fall. So it limits your freedom of movement a little bit, but it's a very effective system, especially if you're going to work on a highly pitched roof like you see in this example. Positioning device systems are things that you often see in scenarios such as window washing. These are where you have a body belt or body harness system which is rigged to allow an employee to be completely supported on an elevated vertical surface such as a wall and work with both hands free while they're leaning. Now obviously a positioning device system has to be designed in such a way as to not create any sort of suspension trauma situations, and work positioning free fall cannot exceed 24 inches if you're going to use a positioning device systems. They have to be secured to an anchorage capable of supporting at least twice the potential impact load of an employee's fall, or 3,000 pounds, whichever is greater. So again, you have to have a competent person to sort of put together and verify the system. Now let's shift our attention to ladder safety. This is important because ladders are a fall protection hazard that pretty much everyone will be exposed to at some point in their lives. The goals of the ladder safety part of this training module is to understand the requirements for safe ladder use, including proper ladder selection, and then understand what the hazards are if you use ladders in an unsafe or incorrect manner. So again, to the question of why ladder safety matters. There's more than 100 deaths in the U.S. that occur every year due to ladder incidents, and around 300,000 injuries. The number one cause of these injuries and these deaths is people falling from ladders. That represents about 60% of all of them. About 10% are things such as strains, sprains, cuts, bruises, punctures, and also electrical shock. Sometimes people place a ladder too close to a power line or a feeder line, for example. %81 of all fall injuries in the United States involve a ladder, so that's 4 out of 5 essentially. And ladder deaths account for 15% of all occupational fatalities. One of the root causes of a lot of these ladder injuries that cause serious injury or death, and about 50% of the time, it results from people climbing a ladder while trying to also carry objects. As we will talk about shortly, you can't safely maintain 3 points of contact while ascending a ladder if you're also carrying something in one of your hands. Here are a few more interesting statistics. When we look at things that OSHA cites employers for, ladder-specific citations are number 5 on the OSHA top 10 list of most cited violations within U.S. workplaces. Most ladder deaths are not from falls from really great heights. Most of them are from falls of 10 feet or lower. In a study funded by NIOSH, it was found that ladder-related claims account for nearly half of all compensable claims. In other words, a case involving time loss, disability, or loss of earning power, in addition to medical expenses. And over the past decade to decade and a half, the number of people who have died from falls from ladders has tripled. This includes household and non-occupational ladder use, as well as occupational ladder use. But still, there's a lot of injuries and deaths that happen on ladders. Let's quickly review some ladder types that you might see in the workplace, or that you might have in your home. This is the basic step ladder. It's got little feet at the bottom to help give you a stable surface, and then it goes up. It's the length that it is. It's not adjustable. This is a very common ladder type. What you also sometimes see are extension step ladders like this one, where it can shorten to a relatively compact length, or it can lengthen to almost double its shortened length. And it's got little feet on it that help to lock the ladder in place so that it doesn't plop down when it's unfolded. This is the A-frame ladder that you see a lot, particularly in indoors and in residential settings, places where you don't necessarily need a lot of elevation gain to do your job. There's different types of articulating ladders that look like this one that can be set up in all sorts of scenarios. In this case, we have one that's set up for example, changing a light that's over a stairwell, and they're designed for this type of operation. This is a tripod ladder, a relatively uncommon design, but you might see it sometimes. This is sort of a modification of the A-frame ladder that's a combination A-frame and extension ladder. Again, it adds an additional level of versatility, and it also has a little bit more stability than a standard step ladder or extension ladder would have. And finally, for cases where storage is an issue, you can actually get a telescoping ladder where every single rung collapses down and like an accordion, and then expands out and locks when you need it to. Now, my concern with that is that it looks like there's a lot of failure points on one of these accordion-style telescoping ladders, so this is not something we have at DRI. I don't think we'll ever get one of these, but it is a type of ladder that exists. Now we'll go over some important ladder safety considerations. You want to always ensure that you have the right ladder for the situation. Not only the right ladder, but you also want to make sure that you're not exceeding the weight rating for the ladder you'll be using. You have to consider both your own weight plus the weight of any tools that you might be carrying up with you in a tool belt. Before you use a ladder, you need to inspect it. You should look for signs of obvious damage or wear and tear, broken or missing parts, and excessive dirt, paint, or other materials that may obscure damage. The biggest thing to look for is examine the rungs. Make sure that the rungs are still firmly attached to the sides of the ladder, and that there's not twisting or any other kind of visible damage to them. If a ladder is broken or defective, tag it out of service. Don't just leave it for the next person to have to find the same problems that you did. Ensure the placement of the ladder is secure and proper. What this means is that the feet of a ladder, whether it's an extension ladder or a step ladder, or even an A-frame ladder, the feet need to be on the same level and on a level surface. There are some ladders that are specifically designed for uneven surfaces where the left side and the right side can be uneven, but most ladders are not designed for that. If you have them on uneven surfaces, the ladder is not going to be straight. And as you climb the ladder and get further from the ground, the chances of the ladder falling to the left or right and taking you with it are greatly increased. For extension ladders and single unit step ladders, you should remember to place them so that the bottom of the ladder is far enough from the support wall to be at a 1-to-4 ratio to the height. So always remember 1-and-4, or 4-and-1 if you will. That's the way that a lot of people remember it, where if you have, in this case you see on this diagram, 4 meters or roughly 12 feet, you need to make sure that the ladder is out about 3 feet from the wall, or from the point that where it touches the top, in this case the roof. If you pitch the ladder too much, it puts a lot of stress on the ladder when you climb it. If you have too severe of an angle, like maybe 4 feet and then half a foot out, the ladder is too straight up, and as a result, when you climb it, there's a greater chance that you're going to fall backwards off of it because you're just the center of gravity is too far back at that point. Also, if you're using an extension ladder or a step ladder to climb up to a roof or to go up a wall, make sure the top of the ladder extends at least 3 feet or 1 meter above the level being accessed. If you're going up under a roof, that ladder needs to go well above the roof line that you're going to climb on. You can't just have it just barely on the top. There needs to be at least 3 feet of clearance. Make sure that the feet are set properly on extension ladders and also step ladders. Again, on the same level, on a level surface. If you have to put them on soft ground, make sure that the feet are set to dig in a little bit. And again, make sure that they're level with each other. If the footings are not level or adjusted to be level, then as you climb the ladder, you're going to get farther and farther off to the left or the right, and that's going to greatly increase the risk of the ladder sliding and you with it. If the ladder is on a hard, flat surface, you want to set the feet flat on it. Again, that's exactly as you would imagine. There's most ladders have a couple different settings on them where you can set them flat or you can set them to actually dig into something. But regardless, you need to make sure that you use a leveler device or some other tool to ensure that the ladder is set right or the ground is sort of built up in such a way that the ladder goes straight up and the feet are level. You want to check ladder stability before placing weight on it or ascending. You can maybe take a couple steps up on it and see if you notice any shifting, for example. But yeah, before you trust a ladder for you to access several feet upwards, take on the first 1 or 2 rungs and see if it stays stable. One of the most important things to remember when you're using a ladder is to maintain 3 points of contact when you're climbing the ladder or going down the ladder. That means both hands need to be on the ladder and also one of your feet. And obviously when you're climbing or descending a ladder, at any given time, one of your feet is probably not going to be on the ladder because it's moving up to the next rung or down to the lower rung. So yes, you need to have 3 points of contact at all times. You should always face the ladder when climbing and descending. Never go backwards down a ladder with your back to it. If you need tools or materials at the level where you're going to be doing the work, make sure that you either use a hoist rope and bucket system or some other means to get the tools and materials up to work level, or ensure that if you have a tool belt, that you can put everything you need in the tool belt. Do not have anything in your hands while climbing a ladder or descending a ladder. This is how a lot of people fall off ladders. This is how a lot of tragedies occur. Do not let this happen. When you're on a ladder and you've gotten up to the point where you're doing the work, do not overreach. The thing to remember with overreaching is, even if you're not wearing a belt, imagine a belt buckle, sort of an object right in the middle of your waist. That object, whether it's a belt buckle or some other visualization of that, must stay between the vertical members of the ladder at all times. If your belt buckle area is getting past the right or left vertical member of the ladder, you've gone out too far. You're overreaching. There's a good chance that ladder could kick out on you, and it could fall, and you could be seriously injured or killed. So do not overreach when you're on a ladder. If you have to go back down and reposition the ladder and go back up, do that. That's a much safer thing to do than trying to overreach when you're on top of a ladder. Never step on the top rung of a ladder, or really any rungs that have a do not step warning sticker on them, as you will often see on the highest or even second to highest step on an A-frame ladder. When you step on the high rungs of a ladder, it's an inherently unstable situation, and you're greatly increasing your chances that you're going to accidentally kick the ladder out, and therefore you're going to fall. This should go without saying, but never move a ladder that someone is on, and never attempt to move a ladder that you are on. You should get down and move the ladder. Unless a ladder is specifically designed for more than one person to be on it at a time, which most ladders are not designed for that and are not rated for that, so therefore, under almost all foreseeable circumstances, only one person should be on a ladder at a time. Never, ever use a step ladder on scaffolding. That's a combination of too many inherently unstable things together. There are much easier ways to get greater elevation, like build an extra couple of bucks on your scaffolding. But using a step ladder on scaffolding is an inherently dangerous activity. If you don't want a ladder to shift while you're up on it, consider tying off the top of the extension ladders to some sturdy object on the roof or along the wall that the ladder is on. As for how to protect yourself while the tying off is occurring, in this case you might have to recruit some help, have somebody hold the extension ladder down at the bottom for stability until it can be tied off. And please, if you're using extension ladders or step ladders or any kind of ladders made of conductive material, always watch out for overhead power lines. And this is not just big power lines, but like the little feeder lines that go into properties. Ladders can reach these surprisingly easily sometimes, so please watch out for this. Now let's show you some concerning ways that ladders are used, and so that maybe you can learn from these bad examples, learn what not to do. I talked before about how you should never use step ladders or extension ladders on scaffolding. Well, these JLG and other lifts are essentially mobile scaffolding, and as you can guess, that ladder is not anchored very well at all. Plus, when you get somebody on a ladder that's connected to one of these lift buckets, that's an awful lot of strain being placed on the lift bucket itself and on the outriggers that you might or might not have down there, or the counterweights they're keeping that lift bucket upright. So this is a recipe for an overturned bucket, for the ladder slipping, and for something really devastating happening. Remember to always position a ladder in such a way that whatever work you're doing, you don't have to overreach on the ladder. Remember, think about the belt buckle. The belt buckle should never go beyond the vertical members of the ladder. You see, obviously, in this case, this person who's painting the sign post. They are greatly exceeding their reach on their ladder, and in fact, they're using that fence for support. And if they were to slip, if that ladder was to kick out, which it could very easily do, they're going to fall right on that fence and become impaled. So, never ever overreach when you're on a ladder. Come back down, reset the ladder, think about different ways of doing it. Never overreach on a ladder. This isn't ladders, but it's a fall protection system, a personal fall arrest system. It looks like it's been through some things. A harness and a lanyard and an anchorage point all need to be periodically inspected to ensure that when called upon, they can do what they need to do. And in this other picture, it doesn't look like we have 3 feet of overhang on that ladder that's gone up to the roof. So when these workers have to descend, it's not going to be easy for them to get on that ladder and to safely go down from it. Plus, it looks like the angle is a little bit more severe than the 1 in 4 or 4 to 1 that we normally like to see. Being able to get a job done, and sometimes we have to think creatively, but when it comes to safety and health and ladders, please don't think creatively. Do not do things that for which the equipment is not designed. On the left here, you see a combination of benches and concrete concrete blocks, and even it looks like a electrical meter being used to support the person working on the side of the house. And then on the other one, you see some ladders being used as scaffolds, and then another smaller ladder being balanced on the scaffold plank. Don't ever get creative. If you don't have the right tool for the job, contact Environmental Health and Safety or facilities. Let us help you find the right tool for the job. Please don't get creative like this. So in closing and in summary, remember these facts. Falls account for the second most workplace fatalities after motor vehicle incidents. Fall hazards should always be respected, and fall protection must be utilized when necessary. Again, remember, there are more than 500 people every year in the United States who go to work and then don't come home because of a tragedy that occurs due to a fall. Fall protection can only be selected and installed by a competent person. Fall protection must be utilized properly in order to work. Ladder incidents account for 81% of all fall injuries. So that's it. Good luck with the quiz. Let us know if you have any questions, comments, or concerns. Thank you for your attention.